All right, so today we will continue with 1.2 for univariate statistics, which will be calculating your MOD. All right, so basically we'll be doing 1.2. Let's look at the learning outcomes for 1.2. What is MOD? By now all of you should know what it means. It's how widespread the data is. So basically 1.1 and 1.2 is just revision from semester 2. All right, so it shouldn't be much of a problem. So this week we will do 1.1 and 1.2, and next week we will do 1.3 and 1.4. All right, so we will separate it nicely. Okay, so how widespread your data is. If your data is more dispersed, meaning your standard deviation will be higher, that sort of thing, all right? So the 4 measures of MOD, which we have done in semester 2, variance, standard deviation, range, interquartile range. Okay, and you must know how to use your calculators to measure all this. I have shared 3 videos for all the 3 different types of calculators on how do you actually use the calculators to basically calculate your mean and standard deviation. So that by far will be, especially for those online, it'll be easier for you to follow up. Okay, so if you're not sure or you have a different calculator altogether, just get in touch with me. And then the meaning of MOD, what does it mean? In terms of variability, consistency, and reliability. We'll be looking at the box plot again. All right, we'll be looking at a box plot again. And then we'll be looking at the relationship between the values, and we'll be looking at skewness. We have basically tried looking at skewness already a little bit, but that's using the mean, median, and mode values. All right. Okay, so basically, I've gone through this. So we will look at this now, right? So I'll go back to your manual. So let's look at these 2 histograms that you see here. Okay, one is less dispersed and one is more dispersed. So whenever it is, first of all, what is dispersion? When your data is very dispersed, when your data is all over the place. Okay, so the first thing that you look at, the most basic thing would be the range, right? So if you look at this, what is the range for this? 14 minus 10, which is 4. What is the range for this? 9 minus 2, which is 7. So from there itself, you can tell the range for the first one is smaller than the range of the second one. That's firstly, you can immediately already say, yeah, your dispersion should be lower in the first one. Okay, secondly, you look at the shape. Look at how widespread is it. You look at the first histogram, it is not so widespread. You look at the second one, there is a gap, so it's quite dispersed. Okay, so the one that is less dispersed has low standard deviation, low variance, low range, and the data is closer to the mean. This one I already mentioned in semester 1. What is standard deviation? How far each data deviates from the standard. The distance of each data from the mean. That is what it means. So if the distance is big, meaning your standard deviation is big, your data is very far away from your mean. Your data is dispersed. So therefore, your standard deviation will be bigger. Your range will be bigger. Your IQR will be bigger. Understand? So look at this one. More dispersed, high standard deviation. This is standard deviation. That symbol is standard deviation. The one with the square is variance. Okay, and then the range also will be higher, and the data will be further away from the mean. Okay, so the 4 measures of MOD, we have done this before. All these formulas you have seen in semester 2 already. This is nothing new to you. All right, this is for ungrouped data, group data without intervals, and group data with intervals. You have done this already, so this shouldn't be a problem. How to calculate, how to plug the values, all you should know. The only new thing for semester 3 is you are now going to use your calculators. Okay, so these are same rules. When you transfer value, you transfer in 4 dp. What does it mean by transfer? You put the mean value inside here, you transfer in 4 decimal place. All answer in 4 decimal place if they don't give you a story. If there are units, 2 decimal places. Wherever required, you need to round off. You round off, follow normal rounding rules. Okay, so now the only new difference is you're going to be using your calculators to calculate your mean and standard deviation. I have shared 3 videos which I've actually requested for you to watch it before coming to class. Okay, I shared it already. So please make sure you watch it, you learn how to use it. Okay, you try to learn first. If you cannot, then you call me and I will try. If you're online, you call me. If you're in class, I will help you out. All right, it shouldn't be a problem. Follow it closely. I totally understand when you start it off, you will feel like I better do it manually. It will be much faster. But let me be honest, in semester 3, if you are going to do it manually, you will have no time to finish your work. You will have no time. I'm repeating this. You must get the hang of using your calculators. Okay, meaning for now, there'll be no more working. You calculate mean and standard deviation 1 mark. Why? Because you plug in your calculator and you just churn out the values. Okay, so I will leave this part. You pause and play as you go along. Use your calculators. All right, use the videos accordingly. Whichever relevant calculators you have, use the relevant videos. Pause and play as you go along. Okay, the videos, they are mostly ungrouped data, and there's also group data with intervals. So same thing, group data with intervals, you will use midpoint. If you have ungrouped data, you just use group data without intervals, you just use your data. You find the mean, standard deviation, and variance. These are the answers in the brackets. Make sure you get the same answers. Change the frequency for data 11 to 15. What does this mean is, this data 11, you change the frequency to 15. This is what you want to do in part B. A lot of students misunderstand the question. Okay, so change it. Basically, for you to change it, there are ways for you to just edit the data. Okay, there are ways for you to edit the data. For those using the Casio calculators, you just go back to data. Okay, you will see a table, right? In the table, you edit it. The 5, you change to 15. You don't go and re-enter all your data back into the calculator. For those who are using the older calculators, the black ones, you will need to scroll upwards and see all the data and go all the way to the second data and change the frequency from 5 to 15. Meaning you go to the frequency of the second data, that means freq 2. You will see FREQ 2. You change, you will see it as 5, right? You put 15, it enter. If you're unsure how to change it, just ask me. You don't need to re-enter the whole data. Please get that. Don't waste time, okay? You just have to edit your data. Those using the newer calculators, you will see a table, right? That you just have to edit the table. You go back to data and you edit the table. That's easy. But those using the black calculators, a little bit more complicated. Not sure? Get in touch with me, okay? I will help you out. I will try to send you a video. It will be easier. Okay? So I need you to get question, the first part of it done, question 3. All right? Let's look at question 4. All right? So now we're going to look at this. So basically, let me go through this. So the meaning of MOD in terms of this. So if you look at these two in your, basically I'm looking at these two, the first two. What happens here is that there is low MOD. The spread is lower. As you can see, the spread is lower. The variability is lower. The consistency is high and the reliability is high. You need to get used to these terms. When I ask you whether that runner is reliable or not. So when you calculate the standard deviation must be low. That means it's consistent. You understand? Anything with low MOD, the consistency is high. Because it is all, it's like this, like what you see here. Do you see this? They are all close to each other. This one, they are all close. So they are consistent. It's all the time consistent. It's in this, about the near. It doesn't need to be accurate. This has nothing to do with accuracy. Okay, it may not be accurate, but it's consistent. Okay, as you can see, they all sit here. They all sit here. Then it is very reliable. Okay, for instance, if I need to choose a student for scholarship and I take his average is good. Okay, maybe all the time he scores well and then maybe just one subject is a little bit bad. But if I take the standard deviation and the standard deviation is, it will become a little bit high because there is one odd value there. That means the student is not very consistent. You understand? Okay, you can be in nothing to do with accuracy here. Consistency and reliability is this. They're all the time the data is very close to each other. Then your MOD is low. Whereas for these two, these are not consistent. These are not reliable. The spread is high. What is variability? Different from one another. That means they're very different from one another. One is here, one is there. So the MOD, measure of dispersion, will be high. All right? So you need to fill this up in your manual. Okay, moving on. MOD and box plot. This is nothing new to you. You have done this before. We're going to do the same thing all over again. 5-number summary, which is your mean, Q1, Q2, Q3 and maximum. You are going to draw the box plot. When you draw box plot, must have scale. Understand? Then you will label it with your minimum, Q1, Q2, Q3 maximum. Okay, you only draw the upper and lower boundary if they ask you to show outlier. We are doing the same thing all over again. Okay, then you'll be commenting on skewness. So if you're not sure, please go back to semester 2, revise. You still, maybe you have short-term memory, you need help, get in touch. Okay. All right, so the reason of skewness would be the presence of outliers. You must remember still how to calculate your upper and lower boundary and how to comment on skewness. The two points, skew to the left or right, 75% of your data is from where to where. Okay, we have done some in the first class, but that was using when your mean is bigger than your median. When your mean is smaller, what's going on, all right? Okay, so I'll just go through this table quickly. If the shape of the distribution is symmetrical, pretty much your mean, mode, median is equal. When it is skewed, you can either be skewed to the left or right. What is the reason for skewness? Presence of outlier and distribution of the data. Your data is concentrated to one end. Okay, when got presence of outlier, how do you, there's only one way to identify outlier, to find your upper and lower boundary. This is, actually we are just flashback only, all this we have done in semester 2. Okay, I will need you to do example 1, all of it. So if you look at example 1, given the 5-number summary, draw the box plot and comment on the shape of the distribution. They didn't ask you to show outlier, please do not bother drawing your upper and lower boundary, all right? Okay, you don't need to actually draw here. It's a teaching slide, it is there. If not, you don't need. Okay? Are we good there? So I need you to complete that. Pause and play and complete. You need to check your answers. Your answers are actually, I've uploaded the answers and I've also put it behind your manual. Those of you who have taken the hard copy. Okay? Example 2, I've given you 2 sets here. X and Y. Okay, these are ungrouped data. So what I want you to do is use your calculators. Okay, use your calculators. I want you to put it in to your calculators. There are 2 ways to do this. If you want to put 10, the frequency 2, 11, frequency 1, 18 also can. Or you want to use it as ungrouped data, also can. All right, you want to put it in as frequency, it's a little bit more faster lah. Okay, I want you to put it into the calculator, find your mean and standard deviation and your variance using the calculator. Okay, that means you put in the X in the calculator, find mean, standard deviation, variance immediately. Then you put in data Y, find your mean, standard deviation, variance immediately. Then you fill up all the other values. All right, please use your calculators. You need to practice. As we go to chapter 2, you'll be using more of your calculators. If you don't get the basic right, you will be lost. All right. Then you need to draw a box plot for each of the distribution using the same scale. Using the same scale means 1 scale, 2 box plots. A lot of students get this wrong. So what I want from you looks like this. Hold on a minute, yeah. Like this. You're going to fill up the table. All right. And then you're going to use 1 scale and draw 2 box plots and comment on the skewness. You understand? Okay? 1 scale, 1 on top the other, like this. I want you to do this. All right? So you pause the video, draw your box plot, check if you've got it right. All right? They didn't ask you to show outlier, so no need to draw your upper and lower boundary. Okay? They asked you to comment on the distribution. Please comment accordingly. By now, all of you should be well-versed. You should know how to comment. You draw. This will be skewed to the distribution. Y will be skewed to the right. Distribution X will be skewed to the left. All right? Okay, so all of you should be quite well-versed. And then here, which of the 2 distributions is more dispersed? How to see which is more dispersed? The higher the MOD, the more dispersed it is. Correct or not? So go back to your table that you have filled up. Which one has a higher MOD? My standard deviation is 6.5, this one. My range, this one is high. So Y is higher, right? So distribution Y is more dispersed. You don't want to write so much. You just write Y, comma, MOD is higher. Is fine. You don't have to answer so much. Always put it in point form. It will be much better. You just put why? Because the MOD is higher. All right? Okay. So exercise 1.2a, I will leave you to do it at your own time. Okay, because basically you're going to be, it's going to be very repetitive. You're going to find all these values for these ungroup data sets and the tables here. So it would be best if you do it so you can practice with your calculators, so you can speed up. Okay, you can speed up. You do it at your own time. Okay, all correct to 2 decimal places. You fill it up. The back has the answers. All right. Okay, this is basically for the example that we did earlier. This one. Okay, we did earlier. Example 1. This is example 1's answers. All right, this is example 1, so you can check when you have drawn. Okay, this is the table that you will be filling up. Just now I was telling you to do it at your own time. So you fill up the table slowly. Okay, fill up the table at your own time. Make sure you try to practice lah. If you don't want to answer so many things, just answer your mean and standard deviation to basically practice your calculators. Okay, mean, standard deviation and variance. Okay, let's look at exercise 1.2b. The box plot below illustrates different distribution. For each one, determine the median, interquartile range, and range. This is easy. Okay, what's your median in the middle? 17. Interquartile range, Q3 minus Q1. 19 minus 14 is 5. Range, 22 minus 12. Okay, you get 10. So basically, you're just going to fill up all. Okay, what is the trick? What I want to teach you here is, initially I taught you when you see histogram, how to comment, right? Now box plot. For the box plots above, which appear to have outliers. Appear, then doesn't mean it has outliers. They look like it has outliers. Which one you think looks like it has outliers? Okay, so let me go to the slide. Okay, so which one appear? It would be B and E. Why B and E? So if you look at this pretty much looks like the left and the right whisker, quite same size. This one, no, right? One so long and one so short. This one looks okay, this one looks okay. See, one so long and one so short. So it would be B and E that appear to have outliers. But in real fact, only B has outlier. They ask you appear, that means looks like. It's not like it's calculated, you know. Would have the smallest standard deviation. Standard deviation comes from the family of MOD. You want to choose the smallest standard deviation, you choose the one with the smallest MOD, which is D. Another trick to it is, the smaller the box, this box, the smaller the box, the smaller the dispersion. The smaller the box, meaning the data is very compact. It is only the smallest and the biggest value that are far. The rest are all concentrated in the middle. Would have the smallest mean. Why? How to find mean? What I told you. If your outlier is small, your mean will be small. If your outlier is big, your mean will be big. So if I'm looking at small mean, I'm looking for the one with the smallest minimum value, which is E, which is 9. All right? Can? Okay, so this is how you answer the questions. This is how you take a look at it. So question 3, competitive pistol shooters. So we've given you the answers here. We're asking you consistency. When they're asking you for consistency, what you want to find is standard deviation. The bigger the standard deviation, the least consistent. The smaller the standard deviation, the most consistent. Plug it in your calculators. Find the standard deviation for all 3. The smallest one will be the most consistent. Okay, so competitor B is the most consistent. You don't need to find mean here, no need. It's just that because it's from the calculators, that's why it's there, but you don't need. An indicator for consistency is always standard deviation. Plug it in your calculators, get the value. Most consistent will be B because it has the smallest standard deviation. Least consistent will be C because it has the biggest standard deviation. Okay, the bigger the standard deviation mean the data is more dispersed. That means your distance of each data from the mean is great. Justify your answer. B is the most consistent as it has the smallest standard deviation. You don't need to actually write so much here. This is a teaching slide. That's why the answer is in full. Okay, let's look at question 4. Now, this is I need to explain this question a little bit. Consider, let me just, give me a minute, so it will be a little clearer. Okay, consider a set of 20 scores arranged in order. So basically what's going on here, they've arranged it from small to big already. 2 of the scores are missing, but the variance for all 20 scores is 25.56. So if they've given you the variance is 25.56, can you find the standard deviation? Yes, you should be able to find the standard deviation. Okay, so you just square root 25.56, you will get 5.0557. You will leave it in 4 decimal places, okay, because they didn't state anything here. Now, would the mean increase, decrease, or stay the same if? So whenever we talk about mean, what should come to your head is extreme value or outlier. The bigger the outlier, the bigger the mean. The smaller the outlier, the smaller the mean. So if the score 25 was removed, now you are removing the big value here, taking this out. When you remove a big value, what will happen to your mean? Your mean will decrease. Okay, score 25 was replaced with 250. Now you're going to put a big value. Outlier is going to be very big. What will happen to your mean? Your mean will increase. Okay, would the standard deviation increase, decrease, or stay the same if? So if we talk about standard deviation, what should come to your mind is consistency. The more consistent your data, the lower the standard deviation. The moment you put more outliers, your standard deviation will become bigger. Okay, if they are more of the same kind of data, that means if my data all 10, 10, 10, 10, 10, 10, 10, very good, consistent, very consistent, meaning my standard deviation will be small. Okay, so let's base on that, whatever we have been doing. The score 2 was removed. Now 2 is here, right? So now if you're looking at a minimum value, the best comparison you can make is to find range. So originally, what's your range? 25 minus 2, which is 23. So originally, your range is 23. Now if I remove 2, you're going to take 2 out, right? They say remove 2. What is your new range? 25 minus 5, which is 20. What does that tell you? Your range has decreased. If range has decreased, your dispersion decrease, so your standard deviation will decrease. This one is very obvious. The score 25 was replaced with 250. Of course, your standard deviation will increase. You are making the dispersion in the data so great. Okay, the outlier is so great, so of course it will increase. All the tens were removed. What are the tens in your data set? The tens is your mode. What is mode? The data that repeats the most. When you take out something that is repetitive in your data, when you have something that is repetitive in your data, what does that tell you? Your data is consistent. When your data keeps repeating the same value, let's say I've marked your maths, all of you get 85, 86, 85, 85, 85. That means your marks are consistent. You understand? So this is consistency. Whenever you have mode, you have data that repeats so many times, it is consistent. So now you are removing the tens, you are removing the mode, you are removing the consistency in your data. What will happen? When you remove the consistency, your data will start becoming inconsistent, which means your standard deviation will increase. So the trick to this is when you remove mode, I will type it out for you. When you remove mode, what happens? Consistency will decrease. Because your mode gives consistency to your data, standard deviation will increase. So remember this. Whenever there's data that's repeating so many times, gives your data consistency, which is good. That means when you're collecting data, you're actually on the right track. It's close to each other. That's what you want. That is what you ideally want when you have a data set. You don't want a data that is, one is so small, one is so big, and it's all over the place. What conclusion can you make from the data? You can't make any conclusion. So you need consistent data that is good. All right, so now you're removing it from your data. That obviously will increase your standard deviation. 6 extra tens were included in the set. Okay, now if you add 6 more tens, good, right? You add 6 more tens to your data means your data is becoming more and more consistent. Okay, because your data is repeating so much. The same data is repeating, that means it's very consistent. Okay, your standard deviation will decrease because it will increase the consistency in your data. Okay, with the interquartile range, what is interquartile range? Q3 minus Q1. Increase, decrease, or stay the same if. So this I will leave you to do. I want you to find where is your Q3 and Q1 position. First of all, you find n. There's 20 data, right? Correct or not? So 20 plus 1 times 0.25 to find Q1, isn't it? Which is 5.25. So your Q1 sits in the 5th and 6th position of your data. So 1, 2, 3, 4, 5 and 6. Meaning this is your Q1 position. A and 9 is where your Q1 sits down. How to find Q3? 21 times 0.75, 15.75, which is your 15th and your 16th data. All right, so where's your 15 and 16 data? This is 20th, 19, 18, 17, 16, 15. So this is your Q3. So this is the position of your Q3 and your Q1. The score 25 was replaced with 250. Will there be any changes? No. Nothing to do with your Q3 and Q1, right? It won't change. When they are replacing means your N also no change. The N is still 20, so position won't change, Q3 won't change, Q1 won't change, IQR won't change. One of the 10s were replaced. Again, you are replacing, so your N no change. So one of the 10s you change to 11, which is this lah probably. Okay, what will happen? When you're replacing things like that, nothing will happen. Because first of all, your N won't change. It doesn't disturb the position of Q3 and Q1. It will stay the same. Now, if the IQR was given to be 3, find the values of A and B. Now, this is more of a guessing game actually. So what A can take what values? A can be 6, 7, 8 or 9. Right? B can be 12, 13, 14 or 15. So I want you to write the possible numbers A can be, the possible numbers B can be, what values can go in A and B that can give you a IQR of 3. 9 and 12. That's the only pair that can give you the IQR of 3. Okay? So basically you write 6, 7, 8, 9. For B, it will be 12, 13, 14, 15. Which pair can give you 3? It will be 12 minus 9. So A will be 9, B will be 12. Okay? So that's number 4. Now up to the last question in your manual. This is pretty direct actually. 6 sets of data are represented in the following graphs. All right? The scales on the horizontal axis are not shown. So they didn't give you any scales. However, the same scales are used. That means they're all from the same scale. You need to match the standard deviations to the histograms. Okay, so first, before I match, I'm going to eliminate the standard deviation that I cannot use. One of it is negative 3.2. Of course, standard deviation cannot be negative. I've said this in semester 2 because you're using square root. When you square root, no value can come out negative. Unless you are learning complex numbers. Okay? No value can come out negative. So we remove negative 3.2 and now we are going to match it. Okay? So how are we going to match it? Let me just adjust this so you're able to see clearly. Okay. So first and foremost, you will see 2 standard deviations which are exactly the same. So let's do that first. 1.053, 1.053. When I have standard deviations that are exactly the same, right? Let's say I have 2 sets of data. Both my sets give me the same standard deviation. What does that tell you? The dispersion in the data is exactly the same. The shape of the distribution will be the same. Doesn't matter if it's skewed to the left or right, doesn't matter. But the shape of the distribution, that means how it's dispersed, it will be exactly the same. That is the only way you can get equal standard deviations. So look at your histogram. Which two histograms look the same? Of course not any of these, right? These are all looking so different. Will be B and E. If you look at B and E, give me a minute. This is okay. If you look at B and E, it's the same. You have one long, one here, and two of the same. One long, one here, and two. It's just that one is skewed to the left and one is skewed to the right. Your skewness doesn't matter. Skewness does not affect your spread, does not affect your standard deviation. The shape of the distribution is still the same, exactly the same. So therefore, B and E will be 1.053. Okay? Let's move to other one, which is obvious, the standard deviation of 0. When I have a standard deviation of 0, what does that tell me? My range is 0. That my mean and my data, there is no distance. There's only one possibility. That means all my data is the same. Let's say 7, everything is 7, 7, 7, 7, 7. If 7, 7, 7, 7, my biggest value is also 7, smallest value is also 7, my range will be 0, isn't it? So, the histogram that will match 0 will be A, because it only has one data set. Understand? Move on to the next one, which will be 0.7. The smallest standard deviation of the three that we have not matched. This will be the smallest of the three that we have not matched. Obviously, the smallest one, now we are left with D, C, and F. The smallest one must be the one with the smallest spread, right? Which will be D. Only 3 sets of data there. That has the smallest spread, so it will be 0.7. Now, you are left with 1.548 and 1.944. Between C and F, which is more dispersed? F, isn't it? Whenever you have a gap like that, you see, this is more consistent compared to this. When you have a big gap like this, suddenly here high frequency, suddenly this one a little bit, then go up. When you have things like this, means it is more inconsistent. So F will be 1.944 and C will be 1.548. Okay, this one students get a little bit confused. This is the last part already. The scales on the box plot are not shown. However, the same scales was used in each one. Match the graphs to the box plots. Okay, what's going on here is I need to adjust this slightly so you can see. Okay, in your manual, the most likely the formatting would have ran a little bit. So this is how it looks like. This box plot represents P. This box plot represents Q. This box plot represents R. Okay? High to low. What does the high to low tell you? This is the small minimum, maximum. Minimum, maximum. Minimum, maximum. Minimum, maximum. Understand? So this one with only one line. That means only one data, right? What does that tell you? This one will match histogram A. Okay? A is U. Now, histogram B and E the box plot must look similar. The two box plot that look similar is P and R. Understand? So you look at the shape. This is small to big, right? So like that, correct? Like that, draw. So B is P. E is R. Understand? Okay? Low to high, small to big. Don't forget to look at that. Okay? Then the next one that we have will be this D. D only got 3 sets of data. What does that tell you? Either my Q1 and Q2 will be the same or Q2 and Q3 will be the same. Okay, so D will match with T. D will match with T. And the one with the highest dispersion is F. F should be S. Q should be C. The bigger the box, I told you, the higher the dispersion. So if you look at this, the bigger the box, the higher the dispersion. Okay, so we will stop here today. And in our next class, we will continue with 1.3. Okay, so today we will stop here.